In this video, we are going to discuss important aspects regarding antennas and communication using electromagnetic radiation. An antenna, in general, is a thin wire of metal that is used to convert normal signals to electromagnetic radiation. An antenna is basically a transducer. It is used to convert guided waves propagating on a transmission line to electromagnetic waves and vice versa. It has got various applications in TV and radio broadcasting, radio wave communication systems, radar systems, cellular phones, automobile anti-collision systems, and etc. Properties and dimensions of antennas. The radiation and impedance properties of an antenna depends on the shape, size, and material of the antenna. Dimensions of the antenna are usually measured in units of wavelength of wave that it is receiving or broadcasting. That in the sense, uh, a 1 meter long antenna transmitting a 2 meter long wavelength is similar to 1 centimeter long antenna broadcasting a 2 centimeter wavelength wave. Reciprocity property. In general, we use antennas that are reciprocal. The the directional function characterizing the relative distribution of the power by the antenna is called antenna radiation pattern or antenna pattern. Most antennas are reciprocal devices exhibiting the same radiation pattern for transmission as well as for reception. Some semiconductor antennas are not reciprocal, and we are not considering them in this PVT. Properties. To fully characterize an antenna, one needs to study its radiation properties and impedance properties. The radiation properties include directional its directional radiation pattern and the associated polarization state of the radiated wave when antenna is used in the transmission mode, also called the antenna polarization. Antenna impedance pertains to the transfer of power from a generator to the antenna or from antenna to a load. Here we see an antenna as a converter from general signal to electromagnetic radiation and the receiver from electromagnetic radiation to signals. And we can also see different types of antenna like the dipole antenna, biconal antenna, loop antenna, horn antenna, etc. And we can also brief a diagram of plane wave approximation. Radiation sources. Radiation sources fall into two categories: current sources and aperture fields. The dipole and loop antennas use current sources. Time varying currents flowing through thin wires produce electromagnetic waves. This is the basic principle behind current sources. Horn antenna is an example of aperture fields. Aperture fields generate electromagnetic waves with the help of time varying electric and magnetic fields across the horn's aperture. But in turn, these time varying fields are reduced by time varying currents in the horn's walls. Hence, time varying currents are the most basic radiation sources. Far field region. A wave radiated by a point source is spherical in nature, with the wave front expanding outward at a rate equal to the phase velocity. The receiving antenna is much far away from the transmitting antenna, then the wave front can be considered planar approximately. This approximation is called far field region approximation and is helpful in mathematical simplification of the situation. Antenna arrays. If multiple antennas operate together, the combination is called an antenna array. The array as a whole behaves as if it was a single antenna and works as the function performed by a single antenna. By controlling the magnitude and phase of the signal feeding each antenna, it is possible to shape the radiation pattern of the array and to electronically steer the direction of the beam. Nowadays, all the antennas that we use are modern versions of antenna arrays using different number of antennas.